Alright guys, today we're going to look at a new kind of graph. So originally we had learned about polar graphing. Now we're going to look at something called parametric equations. So the way parametric equations work is that they add another component that we haven't seen so far. So what we're going to do to graph this function is we're going to make a little chart like we're used to, except there's going to be one extra column. So the way parametric equations work is you have an x and a y component, but both your x and your y coordinate are both can be based off of a t. So the t's, sometimes it'll give you a certain number of t's to graph. So for example, in this case, it tells us to graph all the t's between -1 and 1, including -1 and 1. So those are the different t values I have. So what I'm going to do is, in order to get my x and my y, I'm going to plug in those t's into my equation. So to get that x value, I'm going to do 3 times -1 plus 1. So that's -3 plus 1, which gives me -2. Then to get the y, I'll plug in -1 for y. So I'll get -1 minus 2, which is -3. So what I'm going to be graphing here is going to be the point -2, -3. So I'm just going to plot that point on my graph. Now to get my next point, I'm going to plug in 0. So when I plug in 0, 3 times 0 is 0, plus 1 is 1, and then 0 minus 2 is -2. So I'm going to plot the point 1, -2. Then the last one I'm going to do is I'm going to plug in 1, so I get 3 times 1 plus 1, which is 4. And then I'm going to do 1 minus 2, which is -1. Now, what's going to be a little bit different about these graphs is not only does it stop at a certain point, but what we're also going to show is the direction that we graphed it in as our t's got bigger. So I'm going to add those little arrows on there so I can see my direction. So that's one thing a parametric equation has that we haven't been able to do before. There's no way of knowing which way I graph that line. With a parametric equation, we actually can see that. Alright, now parametric equations also have a corresponding linear function, just like polar coordinates did. And the way we do that is by something called eliminating the parameter. And all eliminating the parameter means is that you're going to get rid of the t. Okay, so I have two functions there. They're kind of hard to see, so I'm going to make them a little darker. And we're going to solve this just like we're used to solving systems of equations. I need to get rid of that t. So in order to do that, I'm going to take one of those equations and get t by itself. Okay, so it's going to be a little bit easier probably to do that on the bottom equation. So all I have to do in the bottom equation is add t, or add 2. So I get y plus 2 is equal to t. So then I can just take that y plus 2 and substitute that in for t. So that means that x equals 3 times y plus 2 plus 1. And now most of these equations that I'm used to, I always have y by itself, so I'll go ahead and solve for y. I'm at a little space, let me move this over. So you can see that parametric equation is really just that linear function. Okay, so limiting the parameter is just trying to find a way to get rid of my t's. And you'll just solve this by getting t by itself in one equation and then plugging it into the other. And you can do this either way. Okay, if you wanted to solve for t in the x equation and plug it in for y, that would also work. Alright, so here's another one. We're going to start the graph the same way. Okay, now it doesn't tell me how much of it to graph. Okay, so I'm going to pick some easy values again. Alright, so I'm going to have a t and then a corresponding x and y. So usually when we graph sine and cosine, one of the easy values that we use is going to be 0. So let's do 0. The cosine of 0 is 1, and the sine of 0 is 0. So 1, 0 is the point of my graph. Right? Some of the other easy values we usually pick for sine and cosine are pi over 2, pi, and 3 pi over 2. So let's plug those in. The cosine of pi over 2 is 0. The sine of pi over 2 is 1. Alright, the cosine of pi is negative 1. The sine of pi is 0. And then the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is negative 1. So then again, we're going to look at where I started. I started at 1, 0, and then I went around in this direction. So I'm going to draw those little arrows to show what direction I went around my circle. Alright, so let's look at a couple of changes here that I can make to this graph. So let's say instead I have 4 cosine t and y equals 4 sine t. So without actually making a chart on this, let's think about how that would change it. Okay, that 4 in front, instead of going through zeros and ones, it's still going to go through zeros, but those ones are going to get multiplied by 4. So this shape is still going to be a circle, except now the radius of this circle is going to be 4. Alright, the next one, I'm only changing the 4 on the x. Okay, so that's going to change my graph a certain way. So if you guys want to see for sure, we can make a chart again. Let's go ahead and do that in this one. It might be a good idea for the first one. So here's t, here's x, and here's y. So if I plug in a t of 0, the cosine of 0 is 1. 1 times 4 is 4. But the sine of 0 is 0. So this graph is still going to go through 4, 0. Alright, now let's plug in pi over 2. If I plug in pi over 2, the cosine of pi over 2 is 0. 0 times 4 is 0. But the sine of pi over 2 is just 1. Alright, now the next one, if I plugged in pi, I would get negative 4 and 0 again. And if I plug in 3 pi over 2, I would get 0, and the sine of 3 pi over 2 is negative 1. So now, instead of having a circle, I have an ellipse. Alright, so what do you guys think is going to happen to this last one, where I'm only putting the 4 in front of the sine? Okay, it's just going to change only the y part, because that y component is the only one that has the number. So it's going to be an ellipse vertically, and it goes through 4 and 1. Alright, now when it comes to eliminating the parameter for equations like this, there's a couple different ways we could do it. I'm going to start with the very first one that we had, which was x equals the cosine of t and y equals the sine of t. Now if I want to eliminate the parameter here, remember I'm trying to get rid of my t's. Okay, so one thing I could do is I can just rewrite this equation. Instead, I'm going to write this as x squared equals cosine squared t and y squared equals sine squared t. So I'm doing the same thing to both sides, so it's not changing my equation. Now what I'm going to do is I'm going to add these. So if I add that left side is going to be x squared plus y squared, and that's still going to have to equal cosine squared plus sine squared. Now, something to think about here, think back to your trig identities. Sine squared plus cosine squared is always equal to 1. So I get x squared plus y squared equals 1. Alright, so that's kind of the algebra behind eliminating the parameter or something like that. What's a little bit easier, and the reason we reviewed circles and ellipses, is if you know that this is going to form a circle with a radius of 4, instead of going through all that trig, it's going to be a lot faster to just go back and say, oh, this is a circle with a radius of 4, the center is at 0, so there's my equation. Or, like this ellipse down here, I know that's centered at 0, 0, and I know that my y-axis is 1, or my x-axis is 1, and my y-axis is 4 squared. That's going to save you a lot of time instead of going through all that with eliminating the parameter. Alright, now the last thing we're going to do is we're going to come up with a parametric equation that fits this last criteria. So what we want here is we want an equation that's going to have a slope of 3 and it's going to go through the point 1, 4. So in order to write a parametric equation, I'm going to have an x equals equation and a y equals equation. Now what we need to think about here is the slope. Okay, so the slope means I'm going up 3 and right 1, which means my y is changing by 3 as my x changes by 1. So the way I could start to write this is my y is 3t and my x is just regular t. That's going to mean every time I plug in a t value, my y will increase by 3 times as much. Now the only thing that's wrong with this is I want to make sure that it goes through the point 1, 4. So one easy way I could do this, if t was 0, then I would have to add 1 to my x-coordinate, and if t was 0, I would have to go through 4. So that's just a simple way to ensure that it goes through the point 1, 4.